Model optimization techniques. In this video we shall see what are bias and variance and how we can optimize our model using hyperparameters tuning. So now I'll be discussing the fundamental problem of bias and variance. So in supervised learning, ideally a model should have two characteristics. It should be sensitive enough to accurately capture the key patterns in the training dataset, and it should be generalized enough to work well on any unseen data sets. So any second point is mentions that any new data set should get accurately predicted, and thus the model should generalize to new inputs. But unfortunately, while trying to achieve the above mentioned points, there is an ample chance of overfitting, and that results in training data points leading to a failure of generalizing the model. So if we train the model too much, it will accurately capture the key patterns, but it will fail to generalize enough so that new inputs won't be predicted accurately. On the other hand, if we try to generalize the model too much, and it will result in failing to capture important regularities. What is bias? If model accuracy is low on both training and test datasets, the model is said to be underfitting and it is said to have a high bias. This means the model is not fitting the training dataset points well in regression, or the decision boundary is not separating the classes well in classification. And two key reasons for bias are not including the right features and not picking the correct order of polynomial degrees for model fitting. To solve an underfitting issue or to reduce bias, try including more meaningful features and try to increase the model complexity by trying higher order polynomial fittings. On the other hand, we'll see now what is variance. So you have a set of training data set and you train your model on that, and it has high accuracy, but on test data set the accuracy drops drastically. Then the model is said to be overfitting or a model that has high variance. So key reasons for overfitting is using higher order polynomial degree, which will fit decision boundary tools well to all data points including the noise of trained dataset instead of the underlying relationship. So this will lead to a high accuracy in the trained dataset, and when applied to test dataset the prediction error will be high. So this implies that if you are using higher order polynomial degree uh, in your model, it will fit well to all the points including the noise of the trained dataset. So this will result in a graph of the model to cover all the points of the training dataset, but when you give it a new input in the form of a test data, the model will give very high prediction error. So to solve the overfitting issue, try to reduce the number of features, that is keep only the meaningful features, or try regularization methods that will keep all the features, however reduce the magnitude of the feature parameter. So we have discussed in the regularization section of our regression lecture. Or next we can use dimension reduction tools that can eliminate noisy features, in turn reducing the model variance, or bringing more data points to make training data set large will also reduce variance. So the more the training data size, the less the variance. Choosing the right model parameters can help to reduce the bias and variance. So for example, using right regularization parameters can decrease variance in regression based models. If you are using lasso or ridge, choose wisely which one to use. For example, so for a decision tree example, reducing the depth of the decision tree will reduce the variance. So these are the ways in which you can reduce the bias and variance. Now we'll see the bias variance trade-off. So on this graph you can see on y-axis the prediction error from low to high, and on x-axis you can see the model complexity from low to high. So the higher the model complexity, the low the prediction error for the training data set, because it fits well to the training data sets well, but not to the test data set. So the variance is high and it is known as overfitting. On the other hand, if the model complexity is low, it won't fit well to the training data set as well as to the test data set. So for both, the prediction error is very high, and this is termed as high bias. So there has to be a trade-off in between both, which is at around this line, in which we can say our model is correct. A very efficient way of optimizing your model is hyperparameter tuning. So one of the primary objectives and challenges in machine learning process is improving the performance score based on data patterns and observed evidence. To achieve this objective, almost all machine learning algorithms have a specific set of parameters that needs to estimate from the dataset. So, so these parameters can be, for example, using a ridge or a lasso regression tool, or whether to use what parameters to use in support vector machine model that you are using. So these all will maximize the performance score depending on what their values are. Assume that these parameters are the knobs that you need to adjust to different values to find the optimal combination of parameters that give you the best model accuracy. The best way to choose good hyperparameter is through trial and error of all possible combination of parameter values. Scikit-learn provides grid search CV and random search CV functions to facilitate automatic and reproducible approach for hyperparameter tuning. So these two functions of grid search CV and random search CV allow you to accurately predict the most beneficial hyperparameter required by your model.